before computer-aided design, there were some drawing staples, technical drawing and drafting, used the type of drawings I'm going to discuss today to communicate their designs to tool makers and manufacturers and other engineers. And what we're looking at here is I have this 3D printed object. It's an object that I call the cat house, and just beginning to look at it, there's a couple of things to note. It's almost a cube. It's a little bit taller than it is wide, but it's got a couple of angled roofs, for lack of a better term, and it's got this like hallway or breezeway that extends through the object. And so this is the front of the object, and what you're looking at here is the top of the object. And what you're looking at here is a drawing that compares these different views. And so what I want to talk about is that these views right here, which depict a non-foreshortened orthographic projection, or orthographic view is what I'll continue to call them as we go through these exercises, but they depict the view from specific angles. This is an isometric drawing, and it's got those views somewhat exploded out in each direction. And what I want to do is kind of talk about these for just a second. We'll call this a front view. If you were in architecture, you might call it an elevation. And if we look at that, that's hatched. That view is hatched here in our isometric view. And if we look at view A, right here, that's what we're looking at right over here. So I'm going to go ahead and just mark this as A, or front. And let's look at maybe the 2 or 3 more important views. So if I take this object and I rotate it 90 degrees this way, which would be like taking this isometric view and rotating it, then I would see this, which is what we're looking at here. So this is an isometric right side view, but that's we'll label it's labeled as C here, and we'll just call it right. And then obviously if I go the other way, rotating it 90 degrees from the front in this direction, then I get this view, and that is what is denoted as D here, and that's the left side view. And before I move on, I want to talk about a couple of things that show up here. You'll even find this when you are in a CAD program like Fusion or SolidWorks, where you have options to have your model displayed as shaded with hidden lines, or even just line work with hidden lines. And what you're seeing here are the hidden lines. So the hidden lines are these dashed lines. And so let's go back to the front view just for a second. And even right here, you're seeing what is visible in that front view. That surface is hatched. So that's what you see right here. But note, in particular, you do not see the hidden line. And so that hidden line in these orthographic views, or orthographic projections, are denoted with a hidden line. Same thing here on the right side. So if I flip it over to the right, I see an object line here, 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 and going around the perimeter. One here that denotes the break or the edge into that roof going back. And so that's what we see as object lines here. And then you see the hidden lines that denote the edges here and here on that right side view. The left side view is the exact same way. It's just a mirror image to where we see object lines here and then the dashed lines. So let's take that out a little bit further. What is E? Well, E is the back view, and it just so happens that on this object that we are looking at, this little cat house, the back view and the front view are identical to one another. In fact, I'm not sure which one I intended to be the front when I printed this and which one I did not. They look exactly the same, with the roof that is facing the viewer angling from the bottom left up to the top right. And so those views are exactly the same. So now let's look at the top view. So I'm going to take this and I'm going to rotate it in this direction. Here's our top view. B, and notice the object lines and the hidden lines here. The object lines are simply of that roof, and the hidden lines, again, of that breezeway, both the edges or the sides of it and the peak of that. And so this is B, and this is a top view. Often you will see, and you are potentially able to communicate the entire geometry of an object like this. Sometimes you're able to communicate it simply with a top, front, and right view. So often you might just see a series of 3 drawings. It may be over the top that we have basically provided an orthographic projection for every face of the imaginary cube that this sits inside of. And so you've got the bottom, F is the bottom view. Whoops. And what you're seeing down here is kind of just a further illustration, in case not all of that makes sense, as to how you might take these views, push the edges together, fold them up, and then wrap them around to essentially become a part of a cube that contains all those drawings. And if we compare the two, this is what we're seeing. Front, right, front, left. Again, the back is identical to the front. The bottom has more object lines than the top, because you actually see the side walls of that inner breezeway and the apex of the roof of the inner breezeway, or the ceiling. And then the top view, which has more hidden lines.